Hi everyone, I'm Akai ID and this is my lab report, Charged Tapes for Physics 2212. A little background on this lab. We were expected to create a net charge on pieces of Scotch tape and measure the excess charge on one piece of tape by observing different interactions. The goals of this lab consisted of gaining a better understanding of the electric force, also known as Coulomb's law, between everyday objects and how electric fields affect matter, as well as visualizing the concept of the transfer of charge. Some physics principles to keep in mind are an object cannot exert a force on itself, like charges repel and opposites attract. Results. I identified the sign of the charge of the Scotch tape to be positive. When I calculated the charge, I got 1.374 e to the negative 8 coulombs, which was within the same magnitude as the textbook example. And I created a virtual representation of the experiment in Python by adding functions to calculate charge and using previous functions from old labs to find the forces. Measurements. I measured the initial height of tape B before I introduced tape A, and when I introduced tape A, the distance between tapes increased. I observed that the charged tape was attracted to the negatively charged pin, which meant that the tape was positive. Net force on tape B is 0 since the tape didn't actually float. The center of mass moved slightly, and the center of mass moving was caused by the repulsion between the pieces of tape. Calculations. Notice how the gravitational force is equal in magnitude to the electric force but opposite in direction, which makes sense since the net force on tape B is 0. And I use this knowledge by setting the two equations equal to each other and isolating Q and plugging in my measurements to find the result. When I did this, I ignored air resistance and treated tape as a point particle with charge concentrated at the center. Ratios. Number of electrons on tape B is the resultant charge, which we found, divided by the electron charge. Number of atoms on sticky side of tape is the tape length divided by the atom's diameter, which was provided for this lab. And the ratio of electrons to atoms is the number of electrons divided by the number of atoms. Here's my code. Click on this link and it'll take you to it where you can interact with my code. Here is my computational model. Notice that the orange arrow is the electric force and that the green arrow is the gravitational force. And this is tape B. Tape A, when we zoom out, there's only one force, supposedly, but in reality, the electric force and gravitational force are equal in magnitude and are in the same direction for tape A. Hit edit this program and you'll see the knowledge behind how I got my computational model. So some final questions. What if electrons had a positive charge and protons had negative charge? Well, the sign of the tape would change for my experiment, but everything else would be relatively the same. Charged objects still attract neutral objects. The U tapes would continue to repel each other, so the laws of physics are not broken. Why is it important to handle the charged tapes as little as possible? Well, I personally faced this problem when the tapes would stop reacting with my hand or another U-tape, and I learned that because of the transfer of charges through contact, the more that I touched the tape, it would lose charge and interactions wouldn't happen as expected. So in conclusion, the lab helped demonstrate the transfer of charge between everyday objects, visualized Coulomb's law, as well as Newton's third law, the reciprocity of forces. And I was successful in calculating excess charges. Thank you so much for watching, and I'll come back with more physics fun.